Back, and now we're going to talk about comets. So let's first mention their size. So a comet typically is between 0.75 kilometers and 20 kilometers in diameter. And to give you an idea of how big that is, look at that first picture there. That's a comet. And then look underneath it, and you see the city of Los Angeles, California. So comets can be very, very big. What are comets composed of? So they're going to be composed of 98% ice. Now the ice could be water ice, it could be carbon dioxide ice, which is dry ice, it could be carbon monoxide ice, and then you see some other kinds of ices that can be found inside of a comet. And then it's going to be 2% dust, and that dust consists of igneous rocks and metals. So notice this is almost the exact reverse of the asteroid. So an asteroid is composed of like 99% rock and metals, but it actually has 1% water inside of it. So if you were to melt a typical meteorite, about 1% of its contents would be water. That's going to be very important because when we talk about the formation of the Earth and then the formation of the Earth's oceans, that's going to play a role. So comets contain water, and also asteroids contain water. I wanted you also to know about the structure of a comet. So the main part of the comet is going to be called the nucleus. And then the closer it gets to the sun, it starts to develop a tail. So what the tail is it's going to be debris that is being blown off of the comet or is changing from a solid to a gas. So normally you're accustomed to water, with water, ice, which is a solid, changing into a liquid, and then the liquid changing into steam, a gas. However, think about what goes on in your refrigerator. So when you open up the freezer compartment of your refrigerator, have you ever noticed that sometimes your ice cubes have shrunk? And that's because they're changing directly from a solid ice into gas. So similarly, these comets that are frozen can change from a solid to gas. So you'd have gaseous water, gaseous carbon dioxide, gaseous carbon monoxide. So it's changing from a solid to a gas. So if we were to draw a picture of, let's say that the sun is over here, and then let's draw a elliptical orbit. So most comets have a elliptical orbit, which means sometimes that they get very close to the sun, and then sometimes they're very far away. Now this part out here, in the furthest from the sun, that's all the way out past the orbit of Neptune, where Pluto is at. So most of the comets that come in close to the sun actually originate way out there past the orbit of Neptune. So the closer they get to the sun, the hotter they're getting. And so here's, let's say, a typical comet, and it's getting closer to the sun. Well, what's going to happen is it's going to start to develop a tail that is going to be pointing away from the sun. And what that is it's material that is changing from a solid to a gaseous state, or it's just material that's being blown off of the comet due to the solar wind of the sun. And you'll notice that comets actually have two tails. So they have what's called the dust tail, and then they also have a gas tail. And then those tails point in different directions away from the sun. Comets can cause damage too. So a well-known example of a comet strike was in 1908 when you had a comet that was only 200 feet across, but it exploded in the air over Siberia, Russia. and it released as much energy as 185 atomic bombs, and it flattened 770 square miles of forest. And so this explosion was so powerful that even in London, England, some of the windows shattered from it. Then it was something like 2 years later that a scientific party was able to make it to the place where this comet exploded, and they photographed it, and you can see those trees there, and they're knocked over like toothpicks 2 years later, and still a tremendous amount of damage was caused by this comet. So where do you find asteroids and comets? So in this picture here, in the lower left-hand corner of the picture, you see the sun, that's that yellow dot, and then it's surrounded by 4 rings. So those 4 rings represent the inner planets. So you're going to have Mercury, and then Venus, Earth, and Mars. Okay, then outside of the orbit of Mars is going to be called the asteroid belt. What do you think is found in the asteroid belt? Asteroids. So it's a debris field in between the orbits of Mars and Jupiter. So it's possible that there was a very small planet there, probably would have been about the size of our moon, and it was torn apart due to the tug of war between the gravity of Jupiter and the gravity of the sun. And then that debris made the asteroid belt. It's also possible that those are original materials from the formation of the solar system that never turned into a planet because of the tug of war between Jupiter's gravity and the sun's gravity. So that's where you find a lot of asteroids. Okay, then you see that those 4 rings are actually the white dot in the middle part of the picture. And so then surrounding that is going to be Jupiter, Saturn, Uranus, and Neptune. And then outside the orbit of Neptune is going to be called the Kuiper belt. Now I know it looks like Cooper, but it's pronounced Kuiper. And in the Kuiper belt, you're going to have both asteroids and comets. So why don't you find very many comets in the asteroid belt? It's because it's too close to the sun. And so it's very close to where the ice line was. And so that, remember we talked about the ice line and the formation of the solar system. So ice really cannot exist in that region. Now there probably is some ice amongst the asteroids, but it's mostly asteroids that's in the asteroid belt. But in the Kuiper belt, it's a different story. You've got both asteroids and comets. And so most of the comets that the Earth sees originate in the Kuiper belt. Also notice that Pluto is in the Kuiper belt. So we think that Pluto is just kind of like debris from the formation of the solar system. Okay, now lastly, that disk of material, the Kuiper belt, is that white dot in the last part of that picture there. And then surrounding that is a gigantic area that is spherical, and that's going to be called the Oort cloud. And in the Oort cloud, you're going to have both asteroids and comets. And this Oort cloud extends halfway to Alpha Centauri, our nearest star. So really, you can think of our solar system as extending from our sun to halfway to Alpha Centauri. So then, from halfway to Alpha Centauri would be the solar system of Alpha Centauri. So the solar system is really, really gigantic. And there could be objects out there in the Kuiper belt that are as big as the Earth, but we just can't find them because it's so far away. All right, we're going to take a break, and when we come back, we're going to talk about factors that influence the evolution of the outer planets.